Okay, now let us continue with access method. So access method refers to how information can be accessed and read into computer memory. There are three methods to access information: sequential, direct access or relative access, and the third access method is indexing access. Okay, now let us see. So this is how sequential access file works, where a file manager uses the address of the last byte read to access the next sequential record. So here the information in the file is processed in order and one record after the other. Basically, sequential access file is not random access. Now this is the example of index and relative files. Right, now this is about free space management. Since our disk space is limited to its storage capacity, we need to reuse the space from deleted file for new files if possible. So in order to uh, to do the free space management, there are 5 approaches here to maintain a free space list. So these are the 5 approaches. However, for our topic, we only cover bit vector and linked list. Now, this is bit vector. So for bit vector, free space list frequently implemented as bit vector. So each block is represented by one bit, either bit 0 or bit 1. Now, this is the example. This is the example of bit vector. Now, let us consider a disk with 30 blocks, right? And each block has the numbers from 0 until 29. Now, if the definition of bit 1 represents free block and bit 0 represents block occupied. Now here, block number 2, 3, 4, 5 and so on till 27 are free. Okay, so these free blocks will be represented by bit 1. Right? And the other blocks which are occupied will be represented by bit 0. So the vector bit would be this one. Okay, so again 0 is the occupied block and 1 is the free block. Now let us imagine each of these bit number represent the block. Okay, again for example, block number 2 here is free. So that is why you can see number 1 here, because this is block number 2. This is from block 0, this is block 1, and this is block 2. Okay, this is block 3. Block 3 is also represented by bit number 1. Okay, here block 3 are free. Then block 4 and 5 are also free. So definitely 4 and 5 are represented by bit number 1. Right? Okay, next. This is about linked list. So in linked list, it keeps pointer to the first free block, and this first free block contains a pointer to the next free disk block and so on. So here block number 2 is free. So it keeps pointer to the block 3. Then block 3 keep pointer to block 4 and block 5. So since block 6 is occupied, then it doesn't have the pointer. And block 5 keep the pointer, goes straight away to block 8. Here. Alright. So in this approach, there is no waste of space and no need to traverse the entire list. Okay, next topic is about directory structure, right? So this is how our computer or the operating system organize the directories. So you must know that we have the directory and we have the files. So you can read about the disk structure, about the term, okay, the concepts for this structure. This is the typical file system organization. This is about operation performed on directory, which I believe you are also familiar with these operations. This is about directory organization. Okay, now this is the thing. This is about directory structure. Okay, so the first structure is single level, right? Single level refers to a single directory for all users. The benefit is easy to support and understand. Okay, now in your computer or on your operating system, Windows for example, you can create multiple users. Okay, you can have admin, you can have user number 1, you can have user number 2, right? Now for single level directory, let's say you have 3 users, but all the 3 users share the same or similar directory, right? For single level directory, the problem is they must have unique names. Okay, so each files must have unique names, cannot be duplicated. Right. Next is two-level directory. So two-level directory, separate directory for each user as a single level directory. Now, for example here, you have 4 users. User 1, user 2, user 3 and user 4. So each of the user has their own directory. For example here you can see user 1 has their own directory here, and user 2 also has its own directory here. Same goes with user 3 and user 4. Okay, next is tree structured directories. For tree structured directories, the tree has a root directory and every file in the system has a unique file name. Okay, this is the logical view of tree structured directory. Okay, and next is acyclic graph directories. For this kind of structure, it allows directories to share subdirectories and files. Example here, as you can see, for the root dict, okay, it has another subdirectories, list, all, w, and count. So count can share one file here. Alright. Okay. And this is about protection. What kind of protection for directory or files, and these are the types of access. Now, how can we define protection or access mode? Basically, we have 3 types of access mode: read, write, and execute. So this slide refers to example in Unix or Linux. Now, RWX refers to read, write, and execute. So each of these access can be defined by 1 or 0. So 1 refers to access and 0 refers to no access. So in this case, if we define 111, meaning that the user can read, write, and execute. Okay, second example, 110, meaning that the user can read, write, but cannot execute. So these numbers are actually in binary form. So 110 in binary, if we convert to decimal, it becomes 6. Right? Same goes with 1, 1, 1. In binary, we convert to decimal, becomes 0. So in Linux, when we want to define the access, we use the command chmod. So here, for example, we use command chmod 761 for directory game. Right. Each of these number refers to, first number refers to owner access, group access, and public access. So 7 refers to 111, meaning that the owner can have or can get read, write, and execute access to directory game. Okay, here number 1. Number 1 refers to 001, meaning that the public cannot read, cannot write, but can execute directory game. Okay, for Windows, we usually use GUI to define the access mode. Right, this is the example of Unix directory listing for the access mode, which I believe you have seen in your lab. Okay, this is about file system structure. Okay, I believe you can read. The layered file system. This is the layered file. Okay, each of the layer from top to bottom, and this is the explanation of each of the file system layers. Right, so this is the exercise I would like you to do. However, please do the quiz that will appear on Edmodo, which represents your attendance for FOC session. Right, that's it for chapter 9. Thank you for listening.